Okay, so good morning, everyone. Good morning, Professor Bogdan Miedzinski.
Good morning, nice to meet you.
I hope you are ready for your invited speech, even if you couldn't come here, but I hope that you will get some emotions from here, from the conference hall. And so I would like to invite the invited speaker, Bogdan Miedzinski from Poland. And the topic is selected problems and prospects of effective BPL PLC application in varied medium of electric grids. So please.
Okay. Mr. Chairman, ladies and gentlemen, I'm just very pleased to have a chance to meet you. However, not personally. Professor, thanks you very much for your efforts done for me to come, but unfortunately I was not able to do that. And I see that you are in a very good condition, not necessarily. The dean is something disabled probably, I don't know what is the reason, but I think that not due to dance, but probably due to work. Okay, thank you very much. Okay, I hope that next time I will come personally and we will meet together. Okay, the topic is selected problems and prospects on effective BPL PLC application in wired medium electric grids. The first is just a moment. Just a moment. Okay. Outline is indicated. Sorry for this disruption. Outline is first a few words about the introduction. This is a work we are performed actually. Next is a few words about the disturbances in the power grid that affect the quality and efficiency of this transmission. Next, a few words about the modeling of communication channel, but a little bit briefly, since the area is very wide. And then what is the most important, I would like to show you some results of a study of BPL transmission efficiency in medium voltage mining network, about the voice and well also the image. And then practical use on BPL PLC transmission mining conditions, not only mining conditions, and then conclusions. About the power line communication, it became last time it became increasingly useful. This technology and this use for, you know, that in the line, it's transmission line and basically used for transport electricity. And commonly is used narrowband power line communication. It means that it is allowed to obtain the maximum speed of about 100 to 200 kilobits per second. And in these applications, the frequency of the carrier is used in the range of about several hundred kilohertz. That's a narrowband power line. And about the BPL and about broadband, PLC is a broadband allowing for transmission with a much higher speed, up to about 200 megabits per second, which indicate that the speed is almost 1,000 times faster than a narrowband communication. And usually the BPL signal is selected in the range from 2 to 30 megahertz. It is noted that practical use has faced serious limitation. Then that it's possible to disrupt the system of military and civil system. And currently the BPL transmission solution offered on the market have the ability to block transmission in forbidden bands. Therefore, it should be mentioned that we cannot also use too high power of the signal, since it can disturb the communication in another channels. Therefore, the limitation, if about practical limitation, is no more than 1 milliwatts, and therefore we can meet this thing. And the main task as your power grids, in which we employ the communication channel of BPL, is, as everybody knows, is a transmission and distribution of electricity. Therefore, all users should meet requirements about the technical conditions and limitation power system. They cannot disturb the official and the practical operation of the power grid. However, the structure and physical characteristics of the networks are different totally from this which you have the traditional communication channels, like in twist and pair, Ethernet, coaxial cable, optical fiber. Therefore, the significant threat, therefore, is due to high frequency disturbances during the operation of power grids, like circuit switching, interruption operation, topology changes, something like this. Also, the big threat is attenuation. Attenuation depends on the type of a cable. Mostly we use a cable, and mining we use a cable. Therefore, attenuation must be carefully selected. One is of effective use seems to be the minimum power grids because of a little probability of a power cable to be damaged. Why we recommend it for use in mining and nowadays even in urban structures? You know, and today we have a war. We have a war, and suddenly you can have outage of electric energy. Therefore, all communication disappeared. I will show you that this connections. I mean, this BPL transportation allow us to communicate, even that we have no any energy when the modems are battery powered. Even when the cable is destroyed, it can conduct the signal via the screens or the armature. That's very important things. And therefore, it results in increasing safety of the mine operation. In miners, we don't mention about the war, but we mind about the mine operation as well. In Europe, usually we have two frequency bands I assigned to PLC technology. Namely, this is a narrow band frequency band, according to Senelec recommendation, is between 3 and 148 kilohertz. That's for low bit rate PLC, and then between 2 to 30 megahertz for high bit rate PLC, being broadband PLC, wideband frequency band. You know that with increase of frequency, usually the attenuation is tremendously increased, with destroy the communication equality. Look, here is indicated frequency bands using PLC technology. On the left-hand side, we have narrow band PLC. On the right-hand side, we have broadband PLC. Here you have indications between A, B, C, D, and is indicated the bandwidth for digital signal, optical for various application, home data transmission, alarm and security system. Not all it depends on the country. In the United States, this for broadband PLC is extended up to about 50 megahertz, but not in Europe. In Europe is limited already about the 30. In Poland is between 3 to 32 megahertz. High bit rate PLC, which is usually between 1 to 30 megahertz, is composed of two sub-bands. First is used for domestic usage internal PLC between 1 to 20 megahertz, and the second between 2 and 30 megahertz is mainly used for middle voltage electrical network public users. Frequency within 1 to 30 megahertz range are used for digital shortwave radio, called DRM, Digital Radio Mondial. There's nowadays is a key radio which can be used. Here you can see the frequencies according to Senelec. Senelec is European Committee for Electrical Standardization band. And here you have a narrow band frequency between 3 and between 95 kilohertz according to the different standards. We are experienced about the application of BPL mostly in a mine. In the mine, in the middle voltage of mine, middle voltage it means between 3.3 kilovolts up to about 40, 60 kilovolts. And in this way, we use the mine power grid infrastructure. However, this infrastructure can be used for the different transmission. Mostly we employ it for audio and video transmission when emergency situation occur. You know, in Poland also we have some accidents, some crash in the mines. Therefore, there are some victims. That very important things is to have a contact with them. And in the case of disaster in the mining, all communication system disappeared. However, honestly, the PLC is not the best quality transmission channel if compared to another channels, but it's more independent and more resistible. And the main advantages of this technology is first of all, is low-cost implementation. We use for this implementation the existing infrastructure of the electrical grid. Also, we get pretty high transmission speed, much higher than is for narrowband, and easy installation. We only need to buy some modems and the couplers, and then to install it at all. We need not to pay extra money for the company. Furthermore, we have it's possible to extend the TPC IP backbone. Therefore, it's possible to use to operate and coexistent on many other systems, not only smart metering or smart grids, like also power grid supervision system, control of street lighting and traffic lights, access system control and monitoring as well. However, for us, the basic goal is to use it for audio and video purpose. If about the application of BPL modems, we have connect them to the cable, to the wire. If about low voltage, there's no any problem, we can do it directly. However, in the case of middle voltage application, due to security, the modems must be joined via appropriate couplers. Here is on the left-hand side, you can see the capacitive coupler. There's a coupler up to about 20 kilovolts. And that's an inductive coupler with a clamp in on this cable. That's a small cable, therefore there's no any problem. The distance, however, is limited. If we are talking about the cable, due to the parameters of cable, mostly due to attenuation, the distance is limited. Therefore, is about a maximum about 1.5 kilometers to about 2 kilometers. Therefore, it depends on many cases, on many types. For example, type of cable or line, or overhead line, if we use this. Also, on the presence of cable box. When we have a cable box, sometimes we have to use bypassing like this. Bus bar also must be bypassed. Therefore, there's leakage of signal. If we have a transformers, you can use a bypass, and already it depends on the type of coupling. Usually, the highest quality is in the capacitive coupling, but the capacitive coupling is not convenient, and sometimes it's dangerous, since we have to connect directly the capacitor coupling directly to the phase being under voltage, and in the case to the ground, everything can disappear. However, this distance can be extended by using repeaters that are installed, therefore the signal to receive it, signal from transmitter, amplified it, forwarded it further. If about the leading company producing, transmitting and receiving devices, they utilize solution that allow for implementation in the 3 hardware configuration. We have a time access, we call it time division duplex, just as I will show you. With a frequency access, we call the frequency division duplex, as shown, and in combined access configuration using both TDD and FDD. If about the time division duplex, we have a gateway masters, then we have a signal, therefore the signal to each, there's a repeaters, and that's received repeaters, and then from repeaters is sent after another time. And therefore, there's a big latency is being involved, and TDC aiding latency, it depends on the exceedancy of the system of around 7 to 10 milliseconds. This is high delay time. However, when we use frequency division duplex, we send to all repeaters the signal at the same time. However, they are resended with different frequency. Therefore, the latency is limited to about 2-4 milliseconds. However, the most convenient is the combining of both, using both techniques, TDT and FDT, however expensive. First, note that if we use a FDD, which compared to the TDD, the number of modems must be double. Therefore, we have to pay for the accuracy and for the speed of operation. We have to pay that. Here is just explanation of that what I already said, and then the the technology is being used. Therefore, if we use the FDD, the data transmission is much shorter, and therefore the best solution is combine TDD and FDD transmission technology. When you use any power line, the transmission, we have to know that there's some disruptive influence of various types of nonlinear electricity receivers. And nowadays, we have a lot of garbage due to high frequency, since we employ a lot of frequency converters. And nowadays, converters are used everywhere, and the modulation is being used everywhere. And under modulation, under processing, signal processing, we have a pulses which destroy tremendously the quality of the transmission. And the different sources of this disturbances may be sources transmitted inside the cable, or also introduced or induced from outside by the inductive of capacitive coupling. And everything is related to the transient states, mostly related to switching operation. If for everybody of you who just tested the garbage in our network, you can see that the disturbances are commonly involved by modern lighting source. Lighting source, if you compare it, if you check it, is involved all the noise. Household appliances, which also use electronic devices, electric storage heaters. First of all, impulse power supplies. And nowadays we use the impulse power supplies. And another way, also, the change of a load is being varied from the inductive load to the capacitive load. Therefore, for compensation is already a problem. Therefore, we have to use the special active filters to do that. Otherwise, we'll not be able to do that. That is a general threat of nowadays of using modern techniques. The example of risk is also being involved by radio service. For example, amateur radio operating in the same bandwidth area between 2 to 30 megahertz. And generally, we have to know not only parameters of a line, first of all, attenuation, but also we have to know the noise. And generally accepted disturbances include so-called color noise, narrow band interference, any impulse disturbances like periodic, synchronous, asynchronous, random, asynchronous, and so on. The so-called white noise results from the superposition. It's like a light, like a white light is the superposition of different color, different wavelengths, and the superposition of different sources of color noise, but of different amplitude and frequency. Its value is usually highest near the technical frequency. The technical in Europe is about around 50 hertz. Sometimes in Switzerland also they use 60 hertz. Sometimes it can appear for some frequency of up to about 20 kilohertz. Narrowband interference, it occurs in narrowband bandwidth is characterized by high value of so-called PCD, power spectral density, and it can arise in the form so-called sharp pins. They are mainly due to the broadcasting activity of radio station operating in the range from this same area. Those narrowband interference frequency are due to this switching performance of numerous receivers like commutator motors. Commutator motors involve also tremendous noise. Impulse power supplied by fluorescent lamp, computers, monitors, printers. They are largely due to digital signal processing like pulse width modulation. Now, each modulation which is being involved here nowadays are the source of the noise. It should be noted that asynchronous pulse disturbance may appear in various parts of power system networks. And we have to take this consideration about that. However, the another disturbances which appear cyclically at the same time are treated as the main disturbances and called background noise. And background noise is unavoidable, is mostly generated by the temperature influence and also by mechanical disturbances as well. The other type of disturbances are random in nature and are generally treated as random impulse noise. Therefore, this must be detected, and in some cases of overexceed of the random, the transformation must be stopped. We selected for the testing this applicability of BPL technology and mine radial cable network. The simplified sketch is indicated here, and is mostly, this is a bus bar supplying here. There's a cable under which we perform our test and theoretical analysis, and it is supplied the selected structure of implementation, the powering converters for especially hoisting machine. Hoisting machine is very big power, and therefore, due to these converters, some damage of voltage waveforms and current waveforms appear in this cable. And therefore, we just tested under non-linear loads with about 6 kilovolt and 80 amps IMS when use a spectrum analyzer that's with resolution less than 1 hertz. And we found out that if about the load, this THD, WDU, total harmonic distortion, if about the value, if about the voltage was relatively low and was within the limit accepted, up to about 3% is accepted for the voltage. Voltage waveform is not usually distorted. However, current sometimes can be tremendously distorted, but also in these cases was not too high. It didn't exceed about 9%. Therefore, you can see that the measured value of resultant THD for the different harmonics will appear between 3 to 11 in 3 different phases, L1, L2, and 3 respectively, under the operation, cable operation. Of course, before employ BPL system, we have to check the background noise. And the background noise measuring and the 6 kilovolt cable under load, it was under load, was measured for both for the capacitive coupling and for inductive coupling, And we found out that for the Bosov type of coupling, the noise, maximum noise value didn't exceed minus 50 decibel maximum. However, for capacitive coupler, which is indicated here, you have a noise, the value practically didn't change with frequency. So for the frequency between 0.5 megahertz to about 33, the limit of this noise is almost the same. The red line is the median value. And this is under the nonlinear load, if about the total harmonic distortion about current was less than 9% the capacitive coupler. If about for the inductive coupler, it is you can see that the noise value slightly decreases with the frequency. However, when comparing to the measurement of unloaded and shorted cable, and for the load cable with a distorted current, we can say that the distortion of a current and the voltage waveform for low harmonic have no visible effect of the value of noise. Therefore, it's this background due to the influence of high harmonic or current voltage of a 50 hertz frequency, something like this, and therefore they are not important. But if about modeling, since you know that it's everything depends on modeling, how high is the transmission grid and how extensive is, how many branches it has. Therefore, it's the transmission technology is based on, in practice, on the result obtained during the research or communication channel. The main implementation task is the testing transmission efficiency with the use of high-speed communication channel. Therefore, in this channel, it is possible to map the branches of power lines that deteriorate transmission parameters. Therefore, when we have multiple branches in electrical network or impedance mismatch, they can cause signal reflection, leading to multi-pass transmission that disturb transmission. And as a result, taking into account the power line, the transfer function can be expressed as here. The model for the transfer function is indicated here, communication channel for the multi-pass transmission. That's H is the power line signal propagation in this range, up to about 20 megahertz. NP is a number of respective propagation paths, if they are. GI is weighting factor, DI is length of I pass. If about the model, we can depict signal reflection. And the signal reflection results from the superposition on the signal coming from the different passes, and then combine each other. The frequency-dependent attenuation are determined by these parameters, I0, I1, and K exponent. The first term expresses the line attenuation, and the second takes into account the signal delay effect defined by the power exponent. This is a signal delay effect, and here you can see there's the length of I pass and the speed of propagation. Therefore, that's everything depends on how what's the power grid, what's the grid. If the grid is simple, is radial, there's no any problem. But however, when there's with many branches, we have to take into account. However, we will consider the only radial lines, and therefore, in this case, we have a consideration, theoretical consideration, and field tests were carried out for inductive and combined capacitive inductive coupler. That's for combined, and that's for inductive coupler, of course, equipped with a special equipment. The cable under study was selected, the mine cable. This is the parameters of that, equipped with central copper screen and equipped with a steel armor to protect them mechanically. They align the faces were separately uniform for each other of a stranded copper conductor. First, we have to analyze the parameters of this cable. I don't show you these parameters since it would take too much time, but we have to create some mathematical model which would be able to depict with a high accuracy our considerations. Where the most important things is to find out characteristic impedance and the propagation constant, as well the power factor. And the basing of these results of Neumann, it was possible to determine the frequency modes used in the BPL Bogdan technology. Before selecting, we have to study the narrowband transmission, allowed to verify accuracy of this assumption. And this was a result of investigation for the sending narrowband for the induction-inductive coupling and for capacitive inductive coupling in this range of frequency. And you see that for inductive coupling, the best range is between 0.5 up to around 6, something like this. For capacitive coupling is between around 1.5 to about 8.5. Therefore, the basing of this testing results, we were able to find out to what kind of mode we have to use. We selected two types of mode when we mark at mode 1. It is between 3 to 7.5 megahertz bandwidth, and mode 11 between 2 and 7 megahertz. And in this case, the broadband technologies was utilized for bidirectional voice from one point to another, from A point to B point and vice versa. Of course, the test was carried out in arrangement, and you see for this year, that special arrangement, you see that's access, that's a capacitive coupler. We have to have access to the naked phase. It sometimes is therefore it must be protected with a fuse. While the fuse which we locate here disturb the parameters of the coupler. And another case is the inductive coupler. We can clamp in on directly on the cable. That's a much more convenient. We can use it in any place which is convenient for us. If about the schematic of signal propagation, doesn't matter what kind of capacity coupler we use, capacity of inductive coupler, from one hand side and another side. That's the forward current, and return current is via earth. Sometimes we use so-called different paths. We use two lines, but for this system, two phases. But for this system, we would have to use only capacitive coupler, which is not convenient in our cases. Therefore, we have developed special equipment, and we check it. The tests were sources from the ITU, that is especially standard. The data sets include signal sample, which was set by two sentences spoken by two female and two male individuals in different languages. The length of each sample was about 7 seconds. We used that the samples was performed in 3 sets: American English, British English, German, and Polish. The original signal was available in 16-bit BPL pulse code modulation format with frequency set to about 32 kilohertz. Next, each sample was coded using this format, OGG format. The degraded samples were processed in 3 bit rates to know how high bit rates we have to use to obtain high quality voice, between 8, 16, and 24 kilobit per second, respectively, when the sampling frequency was changed to 44.1.5 kilohertz. Here you have the indications of applications, couplers. Here are couplers employed on the 2 phases. In this case, is only 1 inductive coupler. Therefore, we use for this purpose, we use a 3-phase cable, about 3 meters long, which is located in the mine shaft headroom selected. And the cable was a part of tested medium voltage radium network of 6 kilovolts of a total length of about 1.300 meters. And to simulate the emergency situation, the tested cable was disconnected from the power supply, was shorted as both sides and as earth at both sides to simulate the emergency situation. The bus quality was obtained of transmission within the frequency range between 2 to 7 megahertz. However, it should be emphasized that the BPL transmission, doesn't matter is a voice or any other signal, is asymmetrical. Therefore, its difference between the some values of the capacity, bit rate, as INS value, signal to noise ratio, as well as CFR, channel frequency response, for different transmission direction. In this case, for example, when we measured capacity from point B to A was related to transmission speech signal was equal to about 27 megabit per second. Therefore, we use a special assessment using the sample was sourced in this, according to this standard. We use a special custom one headphones, and we evaluated in a 5-step most is the mean opinion score, absolute category, random scale, with no reference. And it was ranged from 1, the students estimated it is good quality or bad quality. For the bad quality, they gave a score 1. For the excellent quality, it was given score 5. And it was the study involved a group of 16 people, aged from 25 to 35. There were no disabled people. And the samples were available in this system, pulse code modulation format, with sampling frequency about the 32 kilohertz. Next, the sample was coding with OGG format, and the degraded samples were processed at 3 bits rate, as I already mentioned, whereas the sampling frequency was changed to 44 kilohertz. And then there's an indication that for practical use, you can see the most scale from between 1 and 5 for different bit rate between 8, 16, and 24 megabits per second. You can see that we can assume that the point over 4 is acceptable. The best is much more 4. Therefore, in this case, the most 4. This is an American English language. That's for one capacitive coupling and inductive coupling. There's no big difference here between the type of coupling. And we found out that the lowest bit rate equal to 8 kilobits per second seems to be insufficient. However, the 16 was ranked evidently better. The highest bit rate of 24 kilobits per second for all voice messages were spoken by the male or female lector were clear and it is unstable. The next step was to employ the effective transmission of a picture. Therefore, the analysis was carried out for dedicated cable line, the same, with video samples. However, this is only theoretical work, only just simulations, since we had to stop our testing in the mine due to the disaster, the disease. And that was decoded in this, according to the resolutions, such as pixels, in order to assess the impact of ASNR value on video transmission. Dedicated model of BPL modem was simulated. This model was developed taking into account the following assumption: transmission channel width up to about 5 megahertz, spectrum spreading methods of orthogonal frequency division, 2 digital quadrumode modulation, that is 16 quadrumode amplitude modulation, and 64 quadrumode amplitude modulation as well. Here you can see the structure of a line, of a grid, which can be used not only in mine, which can be used in urban area in the case of some disaster, or in case of war, since the cables, middle voltage and high voltage cables are located in an underground channel. Therefore, in this case, we can employ the special modems and then equip these old modems with battery power. In the practical use, you can send the signal. I don't mention about the preparation of the signal frame. And the signal frame consists of 2,048 orthogonal subcarrier, of which 1,500 represent signal data, while remaining the guard purposes. Example for the square quadrature modulation, including 16, as you see, 67, you can compare here. Here is a comparison of a waveform show it is significant decrease in noise level. Noise level for SR value of 40 decibel, according to the measured results. The corresponding constellation plots of was analyzed. This is for 16, this is for 64. You can see here, you can see that it's much better results. Practical evaluation was assessed also in a 5 points, mean option score scale, on full pixel, like this screen, in a full screen mode. And the viewers is composed of 10 individuals. And the results you can see here, sending from A to point B and vice versa from B to A. And such a picture was sent like walked man, windmill noise, traffic noise, tunnel fountain, tunnel mountain, something like this. You can see that the acceptable level is about 4, like you see here. And you can also see that the big difference between the transmission of video from A to B and vice versa. You can see that big difference. And so far, we don't know why. Therefore, we need to just explain it. Therefore, the further study will include field tests carrying out on real operating mining conditions. Probably that's quite surprising, but it's okay. And at the end, I would like to summarize with the conclusions that everything is here written here. Just let me not read it but present it. That communication continuity and its quality in today's life is of pride importance. That's no doubt. However, they became key factors in emergency cases. And it is in inter area, the mine disaster, when voice contact with injured people is required. This same simulation is similar in the case of blackout or military threat under stoppage of electric energy. Like nowadays we have between Russia and Ukraine. Therefore, in such cases, the use of PLC technology in the middle voltage cable as well as voice transmission channel seem to be absolutely justified. And the cable in mines are laid underground, as are the urban networks in tunnel. They are robust and resistant to mechanical damage and can be effectively used as a transmission medium under energy stoppage, and even in the case of conductor interruption. Even that we have a broken phase, therefore between broken phase we have a gap, and this gap works like a capacity, therefore the signal can go out. And then in order to demonstrate the validity and usefulness of the idea, we have carried out the appropriate test for selected fragment of 6 kilovolt mining cable when connecting a specially developed transmitter and digital receivers to the different modems, BPL. Honestly, I would like to underline that PLC, anyway, is not the highest quality of a transmission channel. With compared to the wireless, with compared to the fiber optics. However, it indicates much more advantages and also is much more cheaper. Therefore, it's worth to use it. Okay, ladies and gentlemen, thank you very much for your attention. That will be all what I would like to present you. Thank you very much.
Okay, thank you. Thank you for the presentation. Do we have any questions from the audience? Okay, so maybe I have one question about reliability of the system. How would you estimate? Is it reliable or no for long distances?
Okay, just we are just under test. Therefore, the reliability was not considered as reliability, but we checked on the possibility of effective channel for the voice. And in this case, we are continuing our investigations since you know that distance is limited. The test what I presented now results was carried out for the relatively short length of cable of around 300 meters. But nowadays we just are able to extend it to about 3 kilometers, but we have to use especially couplers. And the main problem is then if we have a mine shaft is the tunnel down, with about 1 kilometer, that's the problem how to clamp it on the cable. However, it's possible to do that, and we just developed some new capacitor, new inductive capacitor, and then in this case we can employ it and we can test the reliability. However, nowadays I cannot say how high is the reliability since we just perform it only on a few systems. On a few systems, therefore, it's difficult to make statistics. We would have to make more experience. Okay.
So, thank you, and see you probably sometimes after some time here in Palanga.
Okay, I do believe.
Okay.
Thank you very much.